Okay, let's take a look at some of these. Let's run through it real quick. Again, most of this first part is stuff that we did on the quiz, and so you've already shown me to some extent that you've mastered some of this material. Some of it is a little difficult. Actually, these first couple problems are the exact same problems on the review that are the exact same problems that were on the quiz. I mean, same numbers, everything. That's why I put them on the review. Okay? So it's kind of like we're reviewing that quiz at the same time. This first one, pretty straightforward. The biggest mistake people made on this one on the quiz is they did x plus 35 plus 15 equals 180, but that's not the way it works, okay? It's the interior angles that add up to 180. An exterior angle is the sum of the remote interiors. So x equals 15 plus 35, which is 50. The other way of going about that problem, there's two ways to go after this one, okay, is to say, find that angle there first, n, we'll call it. Because 15 plus 35 plus n equals 180, so 50 plus n equals 180. So n is 130, and then use the fact that this angle is 130 and this is a linear pair to come up with the fact that the second angle is 50. Either way works. So you got two different choices on that one. For B, we had, again, the three angles of a triangle add up to 180. And we have to do the algebra. 2x and 3x is 5x is 180. So 5x is 110, divide by 5, and I get x is 22. Okay? For the second one, no, it didn't stay in line. It lied to me. For the second one, we just use a linear pair postulate. Okay, that's something we learned way back in chapter like 2 or 1. Straight lines add up to, two angles that make a straight line add up to 180. I had a lot of people who tried to substitute the 22 in to find y. You didn't need to. There's no need to do any, I mean, it's just 57 plus y equals 180. So y equals 123. Okay? A lot going on here. It's basically common sense stuff. These are not difficult theorems. Most of these facts are facts with the exception of the exterior angle. Everything there could be done with stuff that you probably knew before you started taking this class. You knew before you started taking this class triangles add up to 180. You knew that straight lines add up to 180 before you even started taking geometry. So, pretty straightforward. This is the only one that was a little bit tricky, but because here we did need to know the exterior angle theorem. Because that was the only way to do this one. Here we had to add these two angles up to equal that. That's the exterior angles theorem. The two remote interiors added together equal the exterior. So 90 plus 5x minus 14 equals 9x plus 16. And if you're not sure why that works or how it works, please go back and review that podcast. I think that was 5.3. Because I did a very detailed explanation of why that theorem exists. You can also read it in your book. Okay? So it's in there, exterior angles theorem. 90 minus 14 is 76 plus 5x equals 9x plus 16. And we subtract the 5x and the 16. And I get 60 equals 4x, so x equals 15. Once I know x equals 15, I do have to substitute that in to find the exterior angle. So that's 9 times 15 plus 16. That's 90 plus 45 is 135 plus 16 are 151 degrees. exterior angle. Yeah.
But it's on here, like it says, find the value of x, so would you have to know, like, on the
Oh, no, I'm sorry. I'm thinking about the quiz. The quiz, we had to find the exterior angle. You're right on here. I don't think it says that. Sorry, flashbacks. Spent so much time grading that quiz and kind of drilled in. All right. Classify the triangle by its side and the measure of its angles. Give all appropriate names. Okay? So by sides and angles, we need two names. So how about this triangle? What's one name we could give that triangle? It is a right triangle. That's classification by angles because right is a right angle. And we always classify by the largest angle. What else is it? Isosceles. Isosceles. That's how I say it, to remember how to spell it. Okay? How about this triangle? It is equilateral. What else is it? Yeah. Oh, for the angles too? That's, well, if all the sides are congruent, we know all the angles are congruent, right? I mean, that's one of our theorems, so I only really need the sides. So what do we know? What's another name for it? Triangle, no. Descriptive name of the triangle, yes. This one is actually isosceles, yes. But what else? This one is a special one. It has 4 names. 4, yeah. Acute and equiangular are the other 2. Yep. Equilateral is triangle because it's equilateral and equiangular. That's obvious. It's also acute because all 3 angles are 60 degrees. And it's isosceles because at least 2 sides are congruent. So equilateral triangle is a special one. It's the only one that has more than 2 names. Mostly it's like acute scalene or something, just 2 names, one for sides, one for angles. That's the special case. Okay. Name the corresponding parts and find the given measurements. Now here you do need to be a little careful because you have to notice the notation. The notation tells you what kind of answer you're looking for. Okay? Here it says segment LA is congruent to. So I'm going to name what here? A segment, right? I'm not going to give a length. I'm going to actually give a segment name, right? LA goes with what? GI. And I have to make sure I do segment GI. Congruence means we have to name a segment or an angle, not give a measurement. GI is congruent to, conversely, LA, right? Same statement. M angle L. So am I going to look for the, and what does this mean? I'm actually looking for the actual measure of angle L, right? I want a number. What's the measure of angle L going to have to be? Well, I don't know. It's not given up there, is it? Ooh. What does angle L correspond to? I. Oh, that one's not given either. Uh-oh. Oh, but X corresponds to W, so that has to be 94, right? Oh, so this one has to be 47. So now I can figure out this is 130, 141 together. So that leaves me, what, 39 degrees? There we go. So we have to do a little work to get to that one. Well, on Skyward, yeah. Plenty of activity here. How about angle A is congruent to? Don't say 47, because it's not asking for the measurement, is it? Angle A corresponds to angle G, yep. And I need the angle symbol. If you don't put angle G there, if you just put G there, it does not, the angle is not congruent to a point. Measure of angle G equals, well, I can get that one now. That's easy. 47. Notice it's a measurement. We want a number. And triangle WIG is congruent to what would be the correct corresponding order? XLA. And I need my triangle symbol, right? So symbols are important there. What are they asking for? Now, it didn't say write a full proof here. You notice that we did a lot of stuff with side angle, side, and angle, side, angle, or shortcuts that didn't involve writing full proofs. It says state if the triangles are congruent. If they are, state how you know using which shortcut and write a congruence statement. Yeah. You absolutely have to. Can't wait. Okay. So, for this one, do I have a shortcut here? Which shortcut is being used in this picture for the first one? What are my shortcuts? Let's list them first. What are my possible shortcuts? Side, angle, side. Side, side, side. HL, angle, angle, side, and one more? Angle, side, angle. Okay, so those are things that you obviously do need to have like cemented in, right? Burned down to the hard drive. So what's the first? So which one is being indicated for A, B, C, and D, E, F? HL. Yes, this is an HL because we have the right angle, the hypotenuses are congruent, and the legs are congruent. Okay? It's not side, I mean, if it wasn't HL, it would be angle, side, side, which is not one of our shortcuts. Or side, side, angle. But since the angle is a right angle, that's our special case, that's an HL. Whoop. Help to actually have marker, there we go. HL, okay? And now I need to make a triangle congruent statement. So that means triangle, first triangle can be any order you want. How order would you like to go? ABC is congruent to triangle. Now we got to go in corresponding order. It'd be EFD, yes. EF goes to AB, yep. Okay. There it is. Corresponding order. How about the second one? What shortcut do we have here? Side, angle, side. Now, wait a minute. You got to help me out. I see this side, and I see this side, but where's the angle? Vertical angles, yes. They aren't drawn in, but we may use our knowledge that vertical angles work, so it's side, angle, side. And triangle, let's say go GHI, is congruent to triangle, so G goes with? K, look. See the G has a two-line, is the end of the two-line one? K. So KJI. That's it. You don't have to write a proof. It just says state the shortcut. State if they're congruent. If they are, state how you know. How about this one? Same thing. What shortcut do we have here? Angle, side, angle, yeah. Okay. In triangle, let's go LMN is congruent to triangle. L goes with O. This angle M goes with this angle N. So a lot of the shortcut stuff we do and a lot of the triangle congruence stuff we do isn't full-on proof, is it? It's just identify the shortcut, give the corresponding order. So we don't do everything with full-on proofs. All right. Hey, my cold's only been 3 weeks. I almost have my voice back. It comes and goes. State what additional information is required to order know the triangles are congruent for the given reason. So this is the one that always kind of people struggle with a little bit because they get confused. What I'm telling you is that the triangles are congruent. And I'm telling you the shortcut that we want to use to show the triangles are congruent, but we're missing some information. What information is missing? So we have to pay attention. I want to use side, angle, side. Here's my side. Here's my angle. What am I missing? I'm missing a side. Which side is the question? VW has to be congruent to ZY. There's the statement we need. Okay? It doesn't matter. ZY and YZ with segments you order doesn't matter. You could write YZ. I mean, it's not going to be wrong. Okay? So, and then mark it. I mean, is it side, angle, side now? Yeah, sure. When we look at the picture, it's pretty clear. It's side, angle, side. That's all we have to do. Okay? How about angle, angle, side for this one? All right? Now, wait a minute. This is a little tougher because I only have one angle here given to me, or one side given. I need to be angle, angle, side. Now, I should only need one additional piece of information given because the picture is giving me something too. What's the picture giving me? The picture is giving me the vertical angles, isn't it? Sorry. The picture is giving me this. So what additional information would I need other than what the picture gives me? Which other angle? Which order do we go in? Angle, angle, side. So if I do V, then I have angle, side, angle, don't I? So instead I should do T congruent to angle E. If I did Y, it'd be angle, side, angle, wouldn't it?
But don't I think
Okay. You've got angle. The two angles have to be. The side can't be between the angles for angle, angle, side, right?
I thought it was vertical, like
it doesn't have to. It can be that these two angles are congruent and these two angles are congruent. Okay. Well, and again, you got to go with the order of the parts. That is a little bit tricky. Okay. Find the value of x. This is isosceles triangle stuff. If I have two angles congruent, it means I got two sides congruent. The side's opposite. If I have two sides congruent, I have its opposite angles congruent. Okay? Here are my congruent angles. So that means the congruent sides are there and there. Those are the congruent sides. This one's tricky because it don't just give you the 5x minus 4 and the 16 to make it obvious. You got to choose if the 5x minus 4 is going to be equal to the 16 or the 20. What you may not do and must not do is try to add these three up and set them equal to 180. I can tell you, I see students do that every year. An alarming number of students will do that. They'll say, oh, 3 measurements add them up to 180. 3 what's add up to 180? Angles. Are those angles? No. So don't make that mistake, please. That's a mistake of rushing yourself. You're not thinking, what am I working with? What's the rules for what I'm working with? Okay? Since these angles are congruent, it's these two sides that are congruent, so it's simply 5x minus 4 equals 16, so 5x equals 20, so x equals 4. Pretty straightforward. For this one, a little bit tricky on this one. Does 3x minus 6 equal 30? No, it doesn't, does it? These are the congruent sides, so these are the congruent angles. So this one is also 3x minus 6, isn't it? Oh, now what do I do? Add them up and equal to, because now I am talking about angles, 180. So 3x minus 6 plus 3x minus 6 plus 30 equals 180. So 6x, so it's minus the, sorry, plus, that should have been plus 30. So that's minus 12, that's plus 18 is 180, so 6x equals 162. So that's 30, 29, 20, 27, no, yeah, 27. Okay, so this one we do add up to 180 because they're angles. And that was a tricky one. Honestly, I think that's one of the hardest problems in the review. Because okay. I'm glad you're getting the hard stuff. All right, now we had a proof. Okay, we are going to have proofs on this test. They do account for about 20% of the points, which means if you completely don't get proof and can't even get the givens, if you can get everything else, you can still get a B. Yeah. I'm guessing 2. I'd have to look at it again. I ran it off like last week, Monday or Tuesday, so. They're okay proofs. I think on the test, one of them has actually been fill in the blank. I've got it partially done for you, and you have to.
Oh, see, that's nice. That's a good proof.
So, because I want to see where you're going. Yeah, where do you want to start?
Do we have on the test, we have to keep going after we prove it? Like,
What does it say you're trying to prove? So once we hit that, we're done. That's our finish line. When it says prove, there's your finish line. Okay? Whatever. This is your checkered flag right here, folks. That's where we quit. Once we get there, we quit. So, let's start it out. Okay? Oh, I'm missing some segment markers here. Sorry. All right. So PS is parallel to RT and PQ is congruent to TQ. By the way, when I look at this picture, is there anything jumping out of this picture that we're probably going to want to use at some point? Vertical angles are there. Yep, we're going to want to use that. So file that one. We're going to keep that. Okay? See, you told me you didn't know anything. You knew something. Don't lie to me. All right, so what's your first statement? Okay. And that's given. Okay. What does that, so we'll mark that on there, parallel arc with arrows. When I get parallel lines, what am I looking for? Angles, some alternate interior angles, right? Something like that. Z's. Is there a Z here? There's a couple Z's. Let's just pick one. Okay, right there would be a Z, right? Okay. Well, Z's look like ends when they're turned on this side, don't they? Okay. So angle. So what angles are congruent as a result of that? Angle SPQ is congruent to angle. Okay, QTR would be fine. Let's mark it in. And that's alternate interior angles theorem. Okay. All right, we used our given and we got a congruent part. Now, this is kind of a unique one. I could get a second congruent part from that given if I want to, but I don't need to. I'm not going to need to. But we could. But let's say we just got our 1 and we move on. What's our next given? P congruent to TQ, right? That's given, right? We go through our givens first. Oh, I see where you were going. Okay, so PQ congruent to TQ. Okay. Now, if you'd have done PSQ and TSR as the other alternate interior angles, that would have been okay, and you'd have angle side at this point. But we could also go back to our vertical angles now. We could go back to our vertical angles and say PQS congruent to angle TQR. Vertical angles theorem. And do I have enough now? Do I have a shortcut? I feel like we do. Which one is it? Angle side angle. And I'd say now triangle PSQ congruent to triangle TRQ. Forgot my triangle symbol there. Let's not do that. What? Angle side angle. Now, if you'd have, instead of doing vertical angles, we could have done the other Z, and we might have angle side. Okay? There's actually several ways to do this proof. There's enough there for angle side angle or angle side, depending on how you do it. Because some people may have used the other Z. They may have used angle PSQ and RS and TRQ, and you have angle side, which is just as good. Okay, so more than one way to complete that proof. Which makes it fun for me to grade because I got to really go through it and make sure that, okay, which way are you using? Every step got to be following. Using the vertices of triangle ABC and DEF to prove the triangles are congruent. Oh dear. Okay, little bit tricky because the numbers were big. But we can go ahead. A is at 3, 7. I'm going to go by twos. 2, 4. So 3, 2, 4, 6, 7. There's A. B is at 6, 11. 2, 4, 6. 2, 4, 6, 8, 10, 11. And C is at 11, 13. So 2, 4, 6, 8, 10, 11. 2, 4, 6, 8, 10, 12, 13. This is a really, really obtuse triangle with no straight sides. So there's ABC. And DEF, well, D is at -2 or 2, -4. E is at 5, -8. 5, 2, 4, 6, 8. And F is at 10, -10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Again, they look really obtuse together. All right. So nothing obvious there, right, from our drawing. I don't have any horizontal sides. I don't have any vertical sides. How can I prove the triangles are congruent in the coordinate plane? What do I have to do? Lots of distance formulas, don't I? Okay. When you're doing your distance formulas for this sort of thing, make sure you label what you're finding when you're finding it. AB equals 3 minus 6 squared, 7 minus 11 squared, which is -3 squared plus -4 squared, which is 9 plus 16 equals square root of 25, which is 5. Doesn't matter. It's minus. Minus y1 minus y2 x1 minus x2. Or it doesn't matter, as long as you're consistent. Okay? There's AB. AB would need to be congruent to what in the other triangle? DE. So let's do that right away. Skinny pencil, please. Okay. DE, yes. Question? Oh, okay. DE would be 2 minus 5 squared plus negative 4 minus negative 8 squared. So that's negative 3 squared plus 4 squared is 9 plus 16 equals 5. So these two are congruent. There we go. I just got A, B, and DE are congruent. I now have to repeat that process for BC and EF, and then AC and DF. So 6 distance formulas. Oh, probably a fair amount. I would say somewhere probably around 8 to 10%. That would be a bad idea. Well, come on, guys. Distance formula we've been doing since chapter 1. Okay? This is a proof. It's just a different type of proof. Well, this one requires a little bit more. So now if there were horizontal or vertical sides, that'd be nicer because then I could just, horizontal or vertical sides, you can just count squares, right? You don't have to use distance formula for those. But you still have to state what the length is somewhere. Because we're going to use side, 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 and the proof is going to be showing that the corresponding sides are congruent using a formula. Yeah. Yeah. Okay. Let's finish this one. Okay. This one should be very, very familiar to you. We've seen this before. Given BC bisect angle ABC and ACD, prove the triangles are congruent. BC bisects angle ABC and angle ACD. AB, it should be ABD, I'm sorry. ABD and ACD. Sorry, typo there. So yeah, it's ABD. Yes. There we go. That's given. What does that mean? We spent a lot of time talking about this last week. Okay, that's not what that statement means. Right, that's great, but that's not what that statement of bisecting means. Right, and that's, but again, let's not jump ahead. You're jumping ahead. Okay, it's not like that's wrong, and if you put it next, that wouldn't be wrong, but yes, you didn't finish, you didn't take our given and make congruent parts from our given. Okay, so angle ACB is congruent to what? No. It says this is bisecting this angle, ACB and DCB. Okay, and that's definition of bisect. But it's also bisecting this angle, isn't it? It's bisecting both angles. So what do we get for that? AB, what? ABD is congruent to angle, not ACD. ABD, that's this one. No, we already got this one is congruent to this one. DBC. Yes, because an angle, a big angle, is being bisected.
You mean ABC, not ABD then?
Or AB, I'm sorry, ABC. You're right. I'm sorry, my bad. Okay, and again, that's definition of bisect. Now we can go to CB congruent to CB, which is what? Reflexive. What shortcut are we using? No, CPCTC is not one of our shortcuts. We're using angle side angle. and triangle ABC. Congruent to triangle DCB. ABC, hold on, ABC, DBC. Has to be DBC. Sorry, another typo. Wow, I didn't do well on that one. I apologize. Must have been in a hurry. I don't know. Again, I didn't, it could be, if it was, it'd be a proof like this, since they prove angle A is congruent to angle D, and we'd still do all these same steps. We just add one more step afterwards, and that's when we use CPCTC. Yeah, if it says prove angles or sides congruence, that's going to be a CPCTC step. But again, we still prove congruent triangles first, and then we go to that. Yeah. Let's go back for a second and finish these, because I got time. And I will be checking, by the way, tomorrow when you come in. Have your homework sheets ready to go. In fact, come in before class if you can, and let's get these homework sheets checked off, because I didn't get a chance to check those off today. I need to check your homework points. There's 24 homework points sitting out there with this section, so that's a lot of points. Some of you are all checked off. Some of you still have a few things to do. Be ready to get them checked off. I want to give you the full class period to take the test. So if you don't have it before class, if we don't get it checked off before the bell rings, I'm going to have you set them aside so I can check it while you're taking your test, okay? Or leave it on a back desk or something like that. But if you can be here early, we'll all be here early and we'll all get it done. I mean, most of you are in here, 5 minutes ahead of time. We can get things done quick, okay? All right, let's go back here. I want to show BC. BC would be 6 minus 11 squared plus 11 minus 13 squared, which is negative 5 squared plus negative 2 squared, which is 25 plus 4, or the square root of 29. BC would have to correspond to EF, so EF equals 5 minus 10 squared and negative 8 minus negative 10 squared. Sure enough, that's going to be square root of negative 5 squared plus 2 squared, which is the square root of 25 plus 4, square root of 29. There, I've got those two congruent. Okay. Last. AC and DF. So AC, 3 minus 11 squared and 7 minus 13 squared. So that's negative 8 squared plus negative 5 squared, which would be 64 plus 25, or 89. Square root of 89. And do the same thing for DF. DF is 2 minus 10, or I'm going to do it the backwards, make it nice positive numbers, 10 minus 2 squared plus negative 10 minus negative 4 squared. So that's going to be 8 squared. I'm sorry. That's a 6, so this would be 36. 7 minus 13, I can add and subtract this morning. It must be a Monday. 36, 7 minus 13 is 6, 36, 64, and 36 is square root of 100, which is 10. Plus 6 squared, so that's 64, plus 36 again, which is 10. There we go. When they didn't match up, the first thing I checked was, did I add or subtract wrong? And sure enough, it's like, yeah, 7, 13, that's not a 5, that's a 6. Okay? So there we go. That's what we're going to see tomorrow. If you need some extra help, stop in. I'll be here after school.